Hello, my name is Cedric, and in this week's video, I will be tasked with finding the convergence or divergence of the following series. So the first step I would think of is figuring out which test to run. So some options we have include the ratio test, the root test, the limit test, and the integral test, as well as comparison. So the most computationally intensive test would probably be the limit test. But as you can see, if we run a limit of this, so we change that to a limit and approaches infinity, well, ln is a always increasing function. Even though at the end it tapers off a little bit, it's always going to be increasing. So therefore, we can conclude that as n approaches infinity, the denominator is going to increase infinitely. So therefore, this limit would approach zero, which means that the limit test would be inconclusive. So that means you have to figure out a different test. So I feel like the integral test would be a bit annoying, as this doesn't look like a great integral to take. So the next best thing would be the ratio test, where the ratio test states that if we take this series and we can say limit as n approaches infinity, infinity of a n plus 1 over a n, and if this approaches 0, then we can conclude that the series converges. So let's take a n plus 1 as equal to 1 over ln n plus 2 plus 1 and all that to the power of n plus 1. Now let's just write this over 1 over our original function, which is ln n plus 2 to the power of n. And now let's change this to the limit as n approaches infinity. So now what we can try to do is find the reciprocal. So we rewrite this as ln n plus 2 power of n ln, and we can simplify the like terms, so n plus 3 power of n plus 1. So to solve this limit, a possible solution is figuring out whether L'Hopital's rule applies. But again, this derivative doesn't look great to take because you would have to multiply the exponent in as well as do some other rules, which seems pretty computationally intensive. So I feel like visual testing would be the best option right now. So if we draw these two graphs out, or if you can recall, the ln function would look something like this, right? That's bad. So it looks something like this. But since n plus 3 and n plus, or to the power of n plus 1 of an increasing function, we can conclude that the denominator will always be greater than the numerator. And in that case, as n approaches infinity, we can conclude that that limit would approach 0. Because, let's say, it would be like 8 over 10, and then the next term would be like 64 over 1,000 or something like that. But we can, like, since the numerator here is always less than the, or, yeah, the numerator is always less than the denominator, the term will decrease and therefore approach 0. So now with this, we can conclude that this limit, well, let me copy and paste real quick. So therefore, we can conclude that this series converges to 0 by the ratio test.